Hello all. We will continue our discussion for the day. Today we have service load balancing architecture and other architectures for our discussion today. In the previous classes we had discussed architectures like workload balancing architecture, resource pooling architecture, dynamic scaling architecture, and elastic resource capacity architecture and other things, isn't it? So going forward for our discussion, as I told, so we'll be looking exclusively about the service load balancing architecture. You can take that, in workload distribution architecture as well. We had studied that workload can be either service or a switch or is a network component or any other thing, isn't it, right? So here, though we have one particular architecture exclusively for sharing the workload or distributing evenly the workload, that's a different story. But here in this architecture, or as this architecture aims to properly balance exclusively the service load only. Exclusively service load only. It doesn't bother about other kind of workloads. Okay, you can call this as an a child of workload distribution architecture might be. Okay, but its functionality and its arrangement and its aim is a little bit different from that workload. Okay, so if we go see this architecture, okay, we can observe that the logic behind this architecture's existence is pretty simple. Many clients will be there, okay, and of course the cloud services are being consumed by these clients, and if the load on one such server that is catering to these services, to the clients, okay, is not sufficient enough to handle the request that is coming in rapidly or at due course of time, then automatically the scaling will be happening. This scaling will be happening in terms of the resources, isn't it, right? So what exactly we can tell is if one particular virtual resource is being provided for the service consumption, why? Because exclusively we'll be calling this as a service load balancing, isn't it? And hence we call that as the IT resource that is meant for service consumption. Okay, if it cannot bear the load, then automatically the scaling will be happening in terms of by including other resource, Okay, so what we mean by scaling here is, it doesn't mean like vertical scaling or relocation or other thing. Okay, we just think that okay, there should be some other uh, virtual server or virtual resource, okay, in such a way that that particular entity or else that particular resource will be sharing the load that is coming in. That's the objective, isn't it? Okay, so it is very simple principle behind this. Like if the load is not able to bear by one particular server, then automatically its replica has to be formed. Okay, and that replica should be providing necessary support to the workload distribution. Here in precise, we call that as a service load distribution. And even this server is not able to handle the service request that is coming in, then automatically they should go for another scale of creating another resource, right? Okay, so this is what precisely the principle behind this architecture. It is very simplest principle. It's very simplest principle, isn't it? As the name itself indicates. Okay, when the service load that is being hitting onto the server is not able to bear by that server, then automatically there should be some another server, okay, and this another server will be sharing the load. Even if the second server is not able to bear the load, then there should be coming third server to share the load. Okay. Now the principle is fine. Now let us look into the working culture of this architecture. As you see, there should be a balancer, isn't it? Like how we had observed similar in workload architecture, workload distribution architecture, where you can find a load balancer, isn't it? So here also we'll be having this load balancer. Obviously, this load balancer is the person who identifies whether the distribution of the service should be happening or not, whether the distribution of the service will be happening or not. So while deciding so, okay, the load balancer takes little bit of intelligent model over here. Okay, it takes an intelligent model over here. So it starts measuring the scale of the virtual server itself as it is. Here, what I mean here, the scale is the performance scale of the server. The performance scale of the server. So, for example, service A is hosted on virtual server A. Okay, and all the requests that is coming in will be diverted to the virtual server A to entertain with the service A. Right? Okay. Now, the load balancer, what it does is it plays a scale at the virtual server and observes what is the performance level of the server on service A on the server A, isn't it, right? Now, this as long as this scale, okay, is green in color, that means all the requests that is coming onto this server are properly being handled and they are being entertained. Okay, as long as the scale is green, okay, it doesn't think about even balancing the server. Okay, now if the scale converts, or else if the scale moves to green zone to a little bit of orange zone, okay, then it starts that, okay, it starts thinking that, okay, fine, I need to go for a backup. And hence, when the scale is in orange, okay, it starts creating its resources on a replication basis. That means it starts creating another resource or another instance of the same server to run the service. Why? Because at any point of time, it can grow into red. That means the scale, the performance of that particular server can anytime go into the red. Okay. So in order to react early, why? Because according to the SLA, there should not be any downtime or else breakage while delivering the services, isn't it? So keeping that thing in mind, okay. So when the scale on the virtual server is in orange, that is it is in the medium level of the performance, then automatically it starts creating another instance of virtual server. So the moment when you observe that server A is turning red in terms of the performance, then automatically the load balancer starts diverting the requests or diverting the load to the next instance, and again, in this instance, there will be again a scale to measure the performance of the server. Again, it repeats, okay? Like, now the load balancer will be keeping an eye on both the scales, that is scale on virtual server A and scale on virtual server B, okay? It will be, going through these scales, and accordingly, it will be deciding whether they have to go with the next server or not. Similarly, likewise, okay, it keeps on continuing. It keeps on continuing in such a sense that uh, where is the limit for this continuation? In the sense, either the load should be entirely substantiated or the SLA in terms of the payment, okay, the service level agreement, okay, they have these form the breakage point for that particular replication of the service. Now, what exactly happens here is, while creating more and more number of resources, the load balancer, it has to play a crucial role. It has to monitor upon multiple service scales. So there is a chance for mismatching of the data that is being read from the scales, and the load balancing should be taken care in a proper sense. Okay, so Again, this service load balancing can be happening in two senses. One is the load balancer, the placement of the load balancer itself creates the diversity here. Okay, so if we have the load balancer as a separate entity of the service and it is placed in the cloud as one of the entity of the cloud, okay, and you call that as one type of mechanism. But in another mechanism, what happens is the load balancer will be embedded with the service itself. Interesting, isn't it? The load balancer is embedded with the service itself. That means, okay, let me show you the diagram. So here you can see in this diagram, okay, on the slide, okay, you don't see a separate load balancer as that of the previous one, isn't it? Here, what happens is the load balancer is present within the service itself, within the service itself. So here there will not be any such scales for the performance of the server. There will not be any scales for the to measure the performance of the server. But what exactly happens is, okay, the load balancer, when it is being deployed along with the service, it observes the performance of the service rendering itself. You got it? Okay. So here the load balancer observes the performance of the service rendering itself, and accordingly it takes the decision whether the load is being substantiated with the existing server or it has to be going for alternatives. Okay, that's the diversity here in the service load balancing architecture. Okay, first do understand how it differs from the workload distribution architecture. Okay, and the next thing is how this architecture's major motive and what is the functionality of this architecture, what is the logic behind this architecture, and how these logic can be coming into the existence. Like in this case, like okay, so the load balancer can be happening at two areas. Okay, that is in two locations. It can be present. Either it can be present in the cloud as a separate entity, that is like another resource of the cloud, or it can be present along with the service itself. That means it can be embedded with the, that is load balancer can be embedded with the service itself. Got it? Okay. So wherever the load balancer is placed, the load balancer properly identifies whether the alternative service instance or server instance has to be created or not. Okay, that's about very the simplest thing of the architectures I can tell. That is service load balancing architecture. And the monitoring mechanisms, what you could be finding here is definitely the cloud usage monitor. Definitely the cloud usage monitor. Why? Because the usage has to be properly analyzed. Remember here, we will not be using audit monitor. We will not be using audit monitor. We will be using cloud usage monitor rather than. Why? Because the service is being entirely observed. We don't observe the resources of the cloud. See, remember the workload distribution architecture, you had the audit monitor just because you had to balance all the resources that are present in the cloud, and the workload has to be distributed among them. Isn't it? Here, that is not the case. Here the workload is only in terms of the service, and the service can be taken care in terms of the cloud usage monitor. Okay, and also remember that here the cloud usage monitor plays a crucial role in another sense also. It has to observe how many number of instances it is being created and how much is the duration that these alternate instances are running up. Got it? Okay. So these things are to be properly identified through cloud usage monitor. And the second mechanism is resource cluster. Definitely, as I told, these resources are available or not. That is the kind of clustering we'll be making, isn't it? Okay. So if I say that the backup server has been made, that is the alternative server has been made, but provided it is not available, then the load balancer might not be able to balance the load. That means it cannot be able to direct the load onto the free servers. So definitely there should be a proper clustering mechanism for the resources that is there. Okay, why? Because just it's purely what to say uh, demanding kind of thing. This clustering here, uh, like the kind of services or else the kind of servers that are being identified here as the resource, okay, IT resource. They are to be properly, clustered. Otherwise, the scales that are measuring the performance of these servers will not be giving a proper or else a clear-cut information for the resource administrator to think upon creating other and additional resources or as alternative resources for this particular service. Okay? And obviously, you should be finding another mechanism useful, that is the resource replication. As we talk in both the types of service load distribution, okay, you can think about the replication mechanisms. Okay, only the thing is when it has to be replicated will be guided by the load balancer, isn't it? Right. So that's how the resource replication mechanism is also being implemented in this architecture. This is about service load balancing architecture. We will discuss one more architecture. Again, this is one more interesting architecture, and this is called as cloud bursting architecture. Okay? You people are aware that all the IT resources as of the cloud are called as on-premise and off-premise, isn't it? You know the definition of on-premise and off-premise. On-premise is nothing but the organizational network. Off-premise is nothing but the cloud. Remember that. Okay? So that means there are resources which are in the cloud, but at times, depending upon the situation, we claim that these IT resources can be bursted out onto the on-premise network. That means you have certain resources in the cloud, but the situation demands in such a way that the consumption of this service is very frequent enough, or else the consumption of this service is very demanding in nature, and hence every time instead of going on all the way, all the path in the network to the cloud, okay, they can temporarily burst that server instance or else that service instance onto the on-premise network, and you can see that the service can be catering, or the service can be consumed from the on-premise network only, and finally, okay, finally, when the usage is done, they can be bursted in back into the off-premise network. Okay. I will explain you with the figure or else with the example over here. Okay, let us assume there is a cloud, and in this cloud, you could see that cloud service A is running on, isn't it? Right. So this cloud service A is very much very vibrantly they are being consumed, and hence what the cloud consumer feels that, okay, if we have a cloud service A instance of cloud service A being running in the organizational network itself, then it will be very easy for them to get their functionality done. Okay, they feel so. Okay, so they can go for this kind of architecture. That means the instance of cloud service A can be bursted out into the on-premise network. That means from cloud, the service instance is being made available in the on-premise network, that is nothing but the organizational network itself. So what happens now with the service that is made available in the on-premise network? Now the consumers will not be going all the way to the cloud for this service accessibility, isn't it? Now they have the services here only. They have the service here only. Now consumers start availing the services based upon the instance that is deployed here in the, sorry, I should not say the word deployed, that is bursted out here in the on-premise network only. Okay, right? Now here, how much is the load that the service can be, the bursted service can be taking in? Again, there is a limit here. Again, there is a limit here that not all the load, all the service load can be taken care, or else can be handled by the service instance that is bursted out. Okay, so there is a definitely, there should be a limit on this. Okay, so what happens is the listener, that is the scaling listener, okay, will be placed between the service that is being bursted on the on-premise and the cloud consumers. Okay, and the cloud consumers, and you can observe that this listener is placed in the on-premise network only. On-premise network only. So this listener, what he does is he identifies what is the level or else what is the efficiency of the service that is being bursted out, and to an extent it will be trying to push the service to entertain all the requests, but there will be some break-even point where from which point the service cannot be handled in a proper sense. So during then the service request will be diverted to the service in the cloud network, that is in the off-premise network. That is in the off-premise network. And also there should be some sort of mechanism to synchronize these two services, or else I should say these two instances of the services. One instance is running in cloud, another instance is running in the on-premise network, that is organizational network. Okay, most of the clients service requests are being entertained here in the service instance, which is running in the on-premise network. But if this server cannot take up all the load and still the requests are coming in, then automatically these requests will be diverted directly to the service instance which is running on the cloud. Okay, and basically at the end of the day, neither here, as you see that in the example, if A and B are being catered by the service instance A, which is present in the on-premise network, whereas C is being diverted to the service instance running on the cloud. At the bottom of the day, you could see that neither A nor B nor C are facing difficulties in accessing the service. Okay, they should not be finding any difficulty in accessing the service. Of course, certain breathing level can be allowed. Okay, if there are any interrupts. Okay, but not purely like breaking the functionality or else functional logic of the client. That's how this particular cloud bursting architecture is being identified as the fundamental architecture. Okay, so that's about the architecture, whereas cloud